Sometimes in programming, we need to repeat the same operation multiple times. In order to do that, there are two ways that we can choose from: writing the same code as many times as you need it, or creating a loop to repeat the same operation as many times as you need. Of course, when we code, we want our code to be efficient. What is a loop? It's one of the most useful and commonly used tools in programming, which enables us to repeat the same operation multiple times. Loops come in handy, especially when we are unsure about how many times the same operation will have to be repeated. Maybe 2, maybe 5, or maybe 1 million times. That's where loops are necessary. There are three types of loops in C#: for, while, for each. As stated above, they all have one common task, which is to repeat operations. They can replace each other in majority of the cases. However, we pick and choose the type of loop we need to use based on the task at hand, so as to make our code clean and efficient. All loops have their own advantages, so we need to use the correct type of loop to get the best performance possible. When working with loops, we should always specify the condition at which the loop stops its operation. In case of a bad or incorrect condition, we end up with endless, or in other words, infinite loops. If a loop is infinite, it means that the loop just keeps repeating the operation and never comes to an end. This is a problematic situation that usually results in the program being crashed due to repetition of the same operation. Great! So now you know what repeating tasks are. Let's take it one step further. Let's start with the for loop. The for loop is pretty simple to understand. In most cases, we use for loop when we know exactly how many times the task inside the loop has to be repeated. With for loop, in most cases, you can keep calm and do not worry about ending up with an infinite loop. Why? Let's jump on an example to understand. The for loop syntax in C sharp looks like this. Let's break down our code and see what we've got here. For the operator, for the operator we use to declare a for loop, int I equals 0 is a variable that will last only in the range of the loop. We need this to count how many times the loop will repeat the task. I less than n is the loop condition. The loop will continue to repeat the task until I become equals or higher than n. When condition I less than n becomes false, the loop stops. I plus plus is the increment operator. It increases the value of I closer to n every time loop is repeated. It can be increment, decrement, or even I equals I. If we are changing the value of the variable I within the loop, also, we can create loops inside other loops. There is one thing that you need to pay close attention to and memorize. We cannot declare a variable with the same name in the second inside loop, which is already declared in the first loop. Let's use an example to clarify. As you already guessed, this code won't compile. That is because the variable named int I is already declared in the first loop, and it cannot be duplicated in the second loop again. Let's change the name and make it work. So, now you know the basics of the for loop and how it works. Remember that the loop will continue when the condition is true. After the condition becomes false, the loop stops repeating the task. Now, let's investigate the loop while. We mostly use the loop while when we don't know the exact amount of time the task has to be repeated. The while loop is very useful in those cases. But still, we need to make sure that the loop condition is set properly. Otherwise, we might end up with an infinite loop. Let's see an example to view the syntax of the while loop. Let's break down our code. While loop declaration operator. A less than or equal to 25. The loop condition written between brackets. The task to be done, just like we had in for loop. Let's take a look at an example to see it in action. Let's have a closer look at what is going on after each operation. After first iteration, a plus 5, a becomes 10, condition 10 less than equals 25 is true. After second a plus 5, a becomes 15, condition 15 less than or equal to 25 is true. After third, a plus 5 becomes 20. Condition 20 less than or equals 25 is true. After fourth, a plus 5, a becomes 25. 25 less than or equals 25 is true. After fifth, a plus 5, a becomes 30. Condition 30 less than equals is false, so that loop won't repeat the test again.